Hello guys, so welcome back to the reaction zone. In today's lesson, we're going to look at how to balance the redox equation of the bulb using the Ion-Electron method in basic medium. The Ion-Electron method for acidic medium and basic medium are almost the same. The difference lies in how oxygen and hydrogen are balanced. That's the major difference. So, the first thing we're going to do, just like we did for acidic medium, is to split this redox equation into two half equations. So this is going to be Cr3 plus CrO4 2 minus, and then you have IO3 minus, this is I minus. The next thing will be to determine which of these half equations is oxidation and which one is reduction. The oxidation number of iodine in IO3 minus is plus 5, and the oxidation number of iodine here is minus 1. So there is a decrease in oxidation number in moving from the left hand side to the right hand side. So that tells us that this half equation is reduction, whereas this other one will be oxidation. So we can now proceed to balance the atoms. Just like in acidic medium, we'll start by balancing the atoms that are neither hydrogen nor oxygen. So chromium has one atom here, chromium has one atom here, so it is balanced. Iodine has one atom here, one atom here, it is balanced. So atoms that are neither hydrogen or oxygen are balanced. So let's take the first half equation, Cr3 plus and CrO4 2 minus. The number of oxygen atoms here is 4, and there is no oxygen atom here. So which means that there is a deficiency of 4 oxygen atoms on this side. Now this is where the difference arises when it comes to balancing redox equations in acidic as well as in basic medium. To balance oxygen atoms in basic medium, for each, the key word in this case is each. Each means 1. For each deficiency of 1 oxygen atom, we are going to add 1 water molecule to the side that has the greater number of oxygen atoms and add 2 hydroxide ions, OH minus, to the other side. So it means that for an excess of 1 oxygen atom, you will add 1 molecule of water to the side where there is excess and add 2 OH minus to the other side. So we can see that there is an excess of oxygen atoms by 4 on the right hand side. So we're going to add 4 molecules of water here. And for an excess of 1, we have to add 2 OH minus here. But there is an excess of 4. So it needs to be 2 times 4, which will give us 8 OH minus. So when we look at this now, the number of hydrogen atoms here is 8. The number of hydrogen atoms here is 8. The number of oxygen atoms on the right hand side is 8, 4 plus 4. And the number of oxygen atoms here is 8. So both atoms, oxygen and hydrogen, are balanced. Having done this, the next thing to do is to balance the charges. Plus 3 times 1 for the left hand side is plus 3. Minus 1 times 8 to give us minus 8. The next charge here, plus 3 minus 8 to give us minus 5. On the right hand side, minus 2 times 1 will give us minus 2. This is 0. So minus 2 plus 0 will still give us minus 2. When you look at both sides, discover that the charges are not balanced. And what we do is to ensure that the side with the greater charge is made equal to the side with the lower charge. Minus 2 is greater than minus 5. So what do we do to minus 2 to become equal to minus 5? it will simply be to add 3 electrons here. Because the moment you do that, minus 1 times 3 will become minus 3, and minus 2 minus 3 will give us minus 5. So this is our equation 1. So we come down to the second equation, which is IO3 minus, and this is I minus here. There is a difference of 3 with respect to oxygen on both sides of this half equation. There's an excess of 3 oxygen atoms on the left hand side, and there is a deficiency of 3 oxygen atoms on the right hand side. So for an excess of 1, we have to add 1 molecule of water to the side where the excess is, and 2 OH minus to the other side. Since the excess of oxygen atoms in this case is 3, it means we're going to add 3 molecules of water to this side, and we're going to add 2 times 3, which will be 6 OH minus to the other side. So now let us look at the charges. On the left hand side, minus 1 times 1 is minus 1. On the right hand side, minus 1 times 1 is minus 1. Minus 1 times 6 is minus 6. Minus 1 minus 6 here is minus 7. So the next charge on the right hand side is minus 7. The next charge on the left hand side is minus 1. Minus 1 is greater than minus 7. So what do we do to minus 1 for it to become equal to minus 7 is to add 6 electrons to this side. And then this becomes our equation 2. The next thing is to ensure that the electrons in both half equations are the same. In equation 1 there are 3 electrons. In equation 2 there are 6. 3 is a factor of 6. So to ensure that the number of electrons in equation 1 becomes 6, we have to multiply equation 1 by 2. So equation 1 multiplied by 2 will give us 2Cr3 plus 16 OH minus, and then we'll have 2CrO4 2 minus plus 8H2O plus 6E minus becomes equation 1. Now we can see that the number of electrons in both equations are the same, and we can then cancel them out. And then add the two half equations to get our final answer. So this will be IO3 minus. We're not going to write these 3 molecules of water because we have 8 molecules of water on this side. So when we get here, we subtract this. Plus 2Cr3 plus we have 16 OH minus, but we have 6 here. So subtract the 6 from 16. 16 minus 6 will give us 10 OH minus. And then we have on the other side I minus plus 2CrO4 2 minus plus, we're going to subtract these 3 molecules of water from this 8. So 8 minus 3 will give us 5 H2. And this is the answer to the question. So, the next thing to do is to check if this answer of ours is correct. And we can actually do this by looking at the atoms on both sides as well as the charges if they are balanced. So we have iodine here, we have iodine here, we have chromium here, we have chromium here, the left hand side, right hand side, we have oxygen here, we have oxygen here, we have hydrogen here, we have hydrogen here. And then the charges on the left hand side as well as the charges on the right hand side. So, iodine here is 1, on the right hand side is also 1. Chromium here is 2, chromium here is also 2. Oxygen here is 10. Oxygen plus this 3, that is 13. Oxygen here is 8 plus 5, which is also 13. Then, hydrogen here is 10. Hydrogen here is also 10. Now, the next thing is the charges. On the left hand side, you have minus 1 times 1, which is minus 1, plus 3 times 2, which is plus 6, minus 1 times 10, which is minus 10. And this gives us a net charge of minus 5. And on the right hand side, minus 1 times 1 is minus 1, minus 2 times 2 is minus 4, and this gives us a net charge of minus 5. So this tells you that this answer is correct. Thank you for watching and see you in the next one.